Live from Las Vegas, it's theCUBE, covering Dell EMC World 2017. Brought to you by Dell EMC.
Welcome back. This is Dell EMC World. We are theCUBE. We're here in Las Vegas. Dell EMC World, 3 days of back-to-back coverage. My name is Paul Gillen, and joining me right now, Jason Brown from Product Marketing at Dell EMC, and Narasimha Krishnakumar, Director of Product Management at VMware. And we're going to talk about software-defined storage. What is software-defined storage? Well, everything's software-defined these days, right? Our networks, our servers, our desktops, and now our storage arrays as well. We've been talking a lot about hardware storage at this conference today, but maybe we won't need the hardware so much the same way we use. I don't know. What is it? Let's start with that. Narasimha, what is software-defined storage?
So software-defined storage is managing storage through software, where you have a data plane that resides on any hardware that the customer chooses, and then the software is able to manage that storage. So that's software-defined storage. There are different flavors of software-defined storage, which we are here to talk about. One is hyperconverged infrastructure, which VMware is pioneering with its vSAN technology. And we also have the Dell EMC Scale.io product that is offering customers the capability to run multiple workloads on multiple hypervisor. Jason?
Yeah, definitely. So you think about the evolution of the data center with software-defined. Started with compute, right? VMware did it back in 2001 with virtualization, where they were able to abstract, pool, and automate compute. Then we've got software-defined networking, which has been hot. And now the last part of the SDDC is storage piece. So the key message with software-defined storage is to essentially abstract the hardware, the storage inside the hardware, away from the typical array type architecture, instead running on off-the-shelf x86 servers instead. So you're simplifying the data center, and you're standardizing as well on more common componentry to reduce costs, to increase efficiencies and things like that.
Isn't this what SANs were supposed to be in the first place?
Well, right, so weren't SANs created to get rid of DAS? And what we've seen is that customers are coming to us saying, I have a SAN model, but I'm finding it to be a little too rigid. Or I'm managing multiple silos of SAN, and it's becoming very cumbersome. And then, hey, guess what? What happens after 3 to 5 years? Data migrations, tech refreshes, dirty word, right? And so customers are facing some of these challenges, and so they're looking at software-defined storage to help solve some of those challenges they're facing with traditional infrastructure like arrays.
What you're doing is essentially, you're de-emphasizing the hardware as a vital component in the equation. Isn't that something the Dell EMC wouldn't want to do? I mean, why would you want to make hardware essentially something you don't think about?
Well, it's essentially a portfolio approach. So, think about mainframes. How long have they been around, right? And they won't be going away. Same with traditional infrastructure. For certain workloads, perfectly acceptable to continue running them on traditional array infrastructure. What we're seeing with software-defined storage is that for some of these third platform next generation applications, as well as some less critical workloads, customers are looking to optimize the storage that is being run on, and software-defined storage does that by giving you common hardware with all the goodness, the reliability, the enterprise-grade feature function set, the scalability and performance. It really lives in the software itself, and therefore just gives you a lot simpler data center to not only manage, but also build.
So you say SDS right now is not something that you would use in a mission-critical application. It's something that has a lower performance threshold, perhaps?
So I would say it's not lower performance. It's applicable to most workloads. So if you look at the evolution of the market, x86 workloads have become mainstream. Virtualization is mainstream. Customers have successfully virtualized their data center. Most of the customers that we engage with at VMware have successfully virtualized their data center. For those customers that are there in their virtualization journey and have completed the virtualization journey, they are looking at how do we extend that virtualization to storage and manage storage within the same framework of a server. without having to use a specialized storage array. So we are increasingly seeing that, and most of the customers that are looking at digital transformation and transformation of their data center are looking at how do we take advantage of the software-defined storage where a majority of the applications are running on x86. There are a specialized set of applications that would still benefit from storage arrays, and they are going to preserve those storage arrays for those set of applications.
Now, in storage, you typically would have tier 1 storage or your high-speed storage, tier 2, sort of your mid-range, and then your archival storage. Would you have different SDS solutions for each of these, or would you abstract across the whole range of platforms?
Well, Dell EMC's approach is a portfolio approach. So we don't necessarily have a jack of all trades. So there's various products within the set. So for block storage workloads, you'd have Scale.io. For file-based workloads, something like Isilon. Something with archive and object storage, ECS. So it's more of a portfolio approach in that sense.
But from a customer's perspective, am I abstracting? Am I software defining all of those at once in one common pool, or do I? To what level of control do I still have with where that data resides?
So you do have a level of control as to where that data resides. What we have seen customers do is take a step-by-step approach to software defining their storage portfolio. For example, with the VMware vSAN technology, we see customers that are using virtualization solutions today with the vSphere product that we have. They have external storage systems, and they're looking at how do we take a set of workloads that are running on external storage systems, bring it into the software-defined storage approach. So as Jason pointed out, I think the portfolio, Dell EMC, Dell Technologies portfolio has all the assets for our customers to do this piece-by-piece journey. It's an evolution. It's not going to happen overnight. We believe it's an evolution, and customers will slowly start embracing software-defined storage.
So let's talk about use cases. Right now, what are some of the most appropriate use cases that you're seeing for customers adopting this technology?
So with VMware's vSAN technology, which is hyperconverged infrastructure, the first design goal that we started the product with was VDI. We see a lot of customers that are using vSAN for VDI. Now we are at the 6th generation of the product, and customers have started moving enterprise class applications onto the vSAN platform. They now run Oracle. We are certified for SAP. We offer all the enterprise class features such as deduplication on our all-flash platform, as well as erasure coding. So customers now are embracing vSAN for enterprise class applications, tier 1 applications such as Oracle, SAP, and mission critical applications.
Yeah, and we see some of the similarities as well with Scale.io. We target more enterprise service provider businesses looking to consolidate block storage workloads, looking to build a private cloud, and looking to do third platform DevOps types use cases as well, so containers, OpenStack, things like that. So that's where we kind of target our use cases.
These are not high performance applications. They can maybe be mission critical, but they're not high performance necessarily.
They are high performance in that the IOPS requirements from the storage expected from the storage system are enormous. So for example, vSAN All Flash, a single ready node of vSAN can provide about 100,000 IOPS, and we can scale up to 64 nodes. We are talking about millions of IOPS that are available by the storage subsystem, and we are able to provide a policy-based management framework where they can apply policies with respect to what type of performance requirements the application needs and serve it out of the platform. So these are applications that have high performance requirements as well as a blend of mixed workloads that can be supported by the platform.
Do you work at cross purposes at all with your colleagues on the hardware side where they're trying to sell the virtues of their specific hardware platform, and you're saying, well, put it all in software, we'll all manage it as a pool?
So we do leverage the underlying capabilities of the hardware. For example, NVMe is one such example of a hardware technology that is readily available from our hardware partners. We work very closely with those hardware partners to make sure that the software leverages the performance characteristics that the underlying hardware provides. So at VMware, we take this ecosystem approach where we work closely with the partners, make sure that the drive is capable of providing those IOPS, and we are able to take advantage of those drive characteristics and provide it to our customers.
This is the magic of software-defined storage, right? Depending on your workload and what you're trying to achieve, software-defined storage can support it. So if you do have a high IOPS requirement, you get a bunch of servers with NVMe flash in there, put some 10 gig Ethernet on the back end, and bam, you've got a high performance system powered by software-defined storage. But if you don't have that requirement, then you could build a hybrid type environment where you've got some SSDs as a cache, but you've got more spinning disk at the back end. So that's the magic of software-defined storage, that you're able to actually tailor the environment based on the workload.
Whole new world out there. Jason Brown, Narasimha Krishnakumar, thank you so much for joining us, telling us about this topic that I knew very little bit about, but which clearly is going to be on a radar going forward. We'll be back from Dell EMC World in Las Vegas in just a moment. This is theCUBE.